My name is Sean Schreiber. I'm a DynamoDB solutions architect. I have the pleasure today of stepping you through the Dynamo Deep Dive. And I have a couple years experience focusing entirely on DynamoDB, and I've been with AWS for about 4.5 years. So we're going to go on a journey today, starting with the kind of foundations of DynamoDB, and then we're going to discuss some new features that the service has released this year. We have 2 use cases that we're going to cover, and we're going to showcase some services like DynamoDB Accelerator, DAX, which you're going to learn more about later, and services like TTL, which expire items out of your table. And finally, we're going to leave you with some next steps so that you can get started on DynamoDB today and use the free tier to create your table and create some indexes and use a service like DynamoDB Streams. So Dynamo is a term that kind of originated from the Dynamo white paper in 2007. It was written by employees of Amazon, and 4 of these are in fact still with AWS. For example, Werner Vogels is the CTO of Amazon. Shortly after this white paper is released, in the kind of the history of NoSQL or non-relational databases, Amazon released SimpleDB. And SimpleDB was built on some of the concepts of the Dynamo model, which emphasized availability over consistency. Now, I want to put Dynamo to the side because Dynamo doesn't really represent DynamoDB today. Here we're going to take a look at some of the data that would fit in a non-relational database. These just represent the data, maybe not the actual implementation. For example, if you try to find something that fits really well into Dynamo, Dynamo's somewhere between a key value and a document database. The phrase NoSQL that I've been using comes from a meetup, actually that was in San Francisco in June 2009. We needed a name for the talk, and the idea of NoSQL, some will even say it's not only SQL, came up to describe technologies like Cassandra, HBase, and CouchDB. And of course, between the fall of 2007, when the Dynamo white paper was written, which was sort of a technological foundation of Cassandra, we had SimpleDB, and then in January 2012, we have DynamoDB. Now, since that release, some kind of interesting note that we found, DynamoDB is the highest paid skill according to Novel Aspect, and kind of goes to show you how important it is for a lot of services at Amazon, and a lot of job listings you'll see DynamoDB show up. So why would you use a NoSQL database? Well, with a traditional database, you run into issues when you have massive scale, when you have petabytes of data, and you have high throughput requirements. And so your answer is, in most cases, to scale up your database. In each 2 terms, you'd stay inside the same family. You go from a 2XL to a 4XL node. You get more CPU cores, more memory. But the scaling is done in kind of an incremental way, and it also takes maintenance and downtime in order to do it. And if it's not done right, the performance may not change whenever you change out the database, because maybe it was the volumes that needed to be increased, so you have higher provision capacity. And so to do this properly, you need 2 things. You need technology, and you need a good system in place for change control. Now, looking at a NoSQL database, you scale horizontally by adding in shards. The idea of a NoSQL database, and the fundamental idea, is that horizontal sharding will provide you greater throughput, allow you to host petabytes of data. And in fact, we have customers on DynamoDB today that have over 100 terabytes on a single table, and we have tables operating at millions of requests per second, as we'll show you a little bit later. Now, when you are storing data in DynamoDB or any NoSQL database, it's very important to have a good sharding scheme. The sharding scheme is important because all hardware has limitations. If you create a shard of your database, you don't want to put only your smallest customers there or only your largest customers. You'd rather distribute them across those nodes so you can get the full utilization. In DynamoDB, the key concept here is the partition key, because the partition key decides where the data is going to be stored. Here's some of the ideal scaling conditions for your DynamoDB access. It can often be challenging to have all 3. And when we know that we don't, we know we have to do something about it. We have to find a way to balance our load more evenly. At a high level, the ideal partition key will distribute requests over all the possible key space, which is points 1 and 2. And for the third point, over time, because a database is available every second. And if you're pausing for 5 minutes, maybe you're running on a cron schedule, you have a lot of idle capacity. Here's just some examples of customers who are using DynamoDB, some things that they're running on AWS. I want to point out one that's quite interesting, the tokenization. Tokenization will take something like a credit card number, which is controlled under the PCI compliance requirements, and run it through an encryption system and store it in a database, and then provide you a UUID or some generic ID, which we'll just call a token. So we have customers that are actually storing encrypted credit cards on DynamoDB. We also have other customers who store chat messages on Dynamo. So if you're on a dating app or you have a social media application, you send a message, that may very well be stored in DynamoDB. DataZoo is a customer who's had some success with DynamoDB. They spoke at reInvent last year in 2016. And DataZoo is a petabyte scale marketing platform spun out of MIT Labs. It's a very fast-growing company that helps the world's most valuable brands engage with their customers and applies the data science to the marketing problems. So they run a real-time bid engine. They have over 2 million bid requests per second, billions of impressions per month, and DynamoDB is the cornerstone of their use case. So as you can see here, we have a data moving into this application that runs on AWS through an S3 bucket where third-party data is ingested, and then that data is processed by a data pipeline job that starts an EMR cluster. When the EMR job starts, it initializes with some data from RDS, and then it operates during the load on a DynamoDB table. And the attribution is extremely important for the customer because it helps them to figure out which touch points provide the most value. So they know whether a particular ad that they placed is providing the same amount of value that was paid for it. It's very important for a bidding platform. So they chose DynamoDB for a few reasons. First of all, November and December is massive for them. And so they can scale up their database to match the demand. In addition, DynamoDB has a very predictable cost for them, and they don't have to carry a pager. They don't have to worry about pagers at all. So there's a very strong benefit, a really good reason to use DynamoDB. Their events are stored in a table called user events, and it's created on a monthly rolling basis. And it looks back through a window of 1 month to see the particular impressions or touch points that a customer experienced. So within the table, we have the data stored as a time series per user, and the payloads are compressed binary data. And the attribution works by pulling the event data for a user at the given time and walking backwards from the inserted events. So here's some reasons why customers would use a managed NoSQL service like DynamoDB. They don't need to worry about individual failed nodes in EC2. They don't have to worry about instance replacement or personal health dashboard updates notifying them that the instance needs to be moved or retired. They don't have to worry about EBS volume performance. They don't have to worry about whether I should be using GP2 or PyOps volumes. They don't have to look at CloudWatch metrics on each component of their database, looking at the CPU, looking at the memory, the freeable memory. There's many different characteristics that turn you into a systems engineer if you need to monitor them carefully. And you don't have to deal with notifications or paging whenever something breaks. And finally, when there's a new region, a service like DynamoDB will be there from the very beginning, where in the availability zones where customers are. In fact, when AWS creates a new region, EC2 needs DynamoDB to be up and running because EC2, components of EC2 use DynamoDB. So for that point, we sometimes say DynamoDB is a tier 0 service because it's such a fundamental building block of other organizations inside of Amazon Web Services. So here's some reasons why customers will use DynamoDB. Here's kind of how we position, how we see the service. Most importantly of all, it is highly available. So we'll store your data in 3 physical locations, and we're able to serve those reads at very low latency on the order of single-digit milliseconds. So we'll see read operations under 10 milliseconds. For small items, they can get down well below 5 milliseconds. It's fully managed. You don't have to worry about capacity planning, buying racks. You have a very straightforward limit increase form requesting the amount of throughput you need, and we manage it for you. You don't need to specify per AZ. There's no confusing limits. And very important for our customers, their data is secure. So all the standards that control data in our data center, such as drive destruction, limiting physical access to the hardware, controlling where the data is, who has access to servers, all applies to DynamoDB, so it's an extremely secure service. And of course, you can use IAM policies to interact with DynamoDB because it is a multi-tenant service. So if you want to give a mobile user access to your DynamoDB table, it's fully possible with DynamoDB with a simple set of credentials. So with DynamoDB, Elastic is the new normal. This is a real customer's data, their access patterns over 3 days. We see increases 200% from their normal baseline and 300% for over an hour at the highest point that I've marked here on the picture. And something that is important to note is that this represents millions of requests per second. And there's nothing they had to do to Dynamo to inform us or the service that this load was going to increase. The DynamoDB table was provisioned and ready to go whenever they needed the extra load. Here's just some customers that are using DynamoDB. I want to point out Amazon Marketplace. Amazon Marketplace is just one of many customers inside of Amazon that use DynamoDB. In addition, we have popular gaming companies like Supercell and Zynga. So now we're going to get into the fundamentals of DynamoDB. This is the intro, which goes straight into the deep end. We're going to go into the components of a DynamoDB table, how we do partitioning and sharding, and all these important things. But we need to start with the terminology. In DynamoDB, your data sits inside a table. The table is like a database. The table consists of one or more items. An item is like a row. The items are composed of attributes. You can have one attribute, you can have hundreds of attributes, as long as you keep the item under 400 kilobytes. The most important attribute is the partition key. Without the partition key, which we mentioned earlier, we don't know where your data is going to be stored. And this is because DynamoDB, when it was first released, was a key value database. And now we have some document APIs to kind of help you, but that partition key is critical. Back when the partition key was called the hash, we used to say the hash is king. And now we just have to say the partition key because we renamed it. Now, sort key actually is really well named. The sort key sorts the data on disk. So a common sort key is a timestamp. So if the partition key is device ID, the sort key can be the timestamp whenever a particular piece of data was created. And with the sort key, you get all sorts of rich query capabilities. You can do begins, betweens, statements, and so on. Now, there's 2 types of indexes available for DynamoDB. The first one is the original index that Dynamo released. The local secondary index is similar to going into like MySQL Workbench and going to a column and checking the box to add an index. Because local secondary index is just sorting the data on disk in a different way, so you have fast retrieval. So you have an item that would be maybe written to your DynamoDB table, and then you create up to 5 of these local secondary indexes, and you can choose different dates. Maybe A3 is the date of the product's manufacturer, A4 is the firmware version, A5 could be maybe the timestamp when a data point was created. It's really up to you. There's 2 important things to note about local secondary indexes. They are limited to 10 gigabytes of data, and we have some options in our API so that you can monitor the size of the collections. The second thing to note is that LSIs can only be created when the table is made. They cannot be added afterwards. Unlike global secondary indexes, which are much more common in our designs. Global secondary indexes are essentially DynamoDB rows with attributes completely rearranged. You can choose an arbitrary sorting of your attributes. So for example, if you want to take A1 and make that your sort key or make it an attribute and take A3 and make that your partition key so you can query data on A3, you can do that with a global secondary index. GSIs are a separate DynamoDB table. Now, you won't see it in your console. If you go to the management console for DynamoDB, you'll see the table name. But you have to go to the indexes tab to find the GSIs. But to AWS, they are, because they have table names, they have IDs, they have a partition and sort key that you define. And most importantly, they have provision capacity. Now, I say that because the DynamoDB global secondary indexes require paid-for pre-provisioned capacity, just like a normal DynamoDB table. So when we say RCUs and WCUs, we're talking about read and write capacity units, which we'll go into detail here in another slide or two. Something that I mentioned and that's worth repeating, they can be added or removed at any time. So if you decide that A2 needs to be indexed, you can use A2 as your partition key. A common example for global secondary indexes is creating a normal Dynamo-based table with a partition key of a user ID, and then creating a global secondary index on the email. So you can do a query based on the email or the username. Here's some data types. We like to throw this slide up, and I like to do it. I made it so I could show you what data types might exist that you're comfortable with, such as timestamps and blobs, and how they map to the DynamoDB API data types. Dynamo supports strings, numbers, binaries, and sets of string numbers and binaries, nulls, lists, maps, and booleans. So if you have a JSON document, you can store in DynamoDB. If you have a date time, you can store it in DynamoDB, but it has to be as a number or string. And if you have a map data type, which is a JSON document, you can store it directly as a map. And I should also mention, we have document SDKs to assist you with storing data in DynamoDB natively. So if you have a Python dict, you can store it directly as a map and get it back as a dict. If you have a map or a hash map in Java, you can convert it to a map and back using the document SDKs. So we're going to talk about what it takes to create a table. What am I going to choose? We're going to kind of summarize everything we covered. You know, the partition key is always required. The sort key is optional, which is why it's italicized. The provision capacity is selected when the table is created. We'll kind of show you kind of what that is here in the next slide, but you have to choose at least one capacity unit per second. And you get to choose what the indexes are going to be. You could add an LSI or GSI on creation. Optionally, you can enable TTL by specifying the attribute that's going to use to expire items, and we'll go into detail later, or auto-scaling, which we have a slide on as well. And auto-scaling allows you to control the table's consume capacity based on, or provision capacity based on the consume capacity. Provision capacity is specified in read-write capacity units. One RCU returns 4 kilobytes of data for, in most cases, for strongly consistent read units, but there is a separate type of read, an eventually consistent read unit, which gives you twice the amount of data for the same price. You also have a WCU, which is also provisioned per second, and a single WCU will get you let you write 1 kilobyte of data. Now, taking a step back, in terms of non-relational databases, how do you increase the capacity of your database? Well, you add in more hosts. Each one's going to bring more compute, more storage, higher network bandwidth. And when you interact with DynamoDB, you're going to be talking to partitions. So we're going to be adding more partitions. These partitions or these hosts give you let you go to millions of requests per second and tens of millions of IRs. So in Dynamo, these are called partitions, and as you can see, we have the 3 products here in a customer's orders table. The top product is an Echo, the middle is a Paperwhite, the bottom is a Fire TV. We said that the hash is king. The partition key is the most important thing because we run that through a consistent one-way hashing function. The output of that hash will fall in a section of the key space. We've made a simple hashing system where the minimum key is 0, the positive is FF. So as you can see, each partition is responsible for a section of that key space. So after we run the hash and we move the items, they're all going to kind of crisscross. And so an item is going to sit on exactly one partition. Now, there are 2 situations where you will have more partitions be added to your table. Now, the first is when you are splitting for size. Size means you're crossing the 10 gig boundary, which is the desired size for a partition. So we're going to divide half the data, put half of it on one partition, in this case partition D, the other half on partition E. We're also going to divide up the provision capacity because the provision capacity is distributed. And we use essentially a formula that says each partition should be about 10 gigabytes. If it goes over 10 gigs, we're going to try to split it. The second reason why more partitions would be added to your table is if you increase the provision capacity. The provision capacity, increase will bring in more partitions if the change would cause one partition to exceed the maximum throughput that we want it to. We have a formula. It's in our documentation. I won't go into detail here. You can check out our guidelines on working with tables. It's our best practices documentation. You can see that formula. More partitions gets you higher throughput. It lets you, achieve scale. And there's something important to note that your latency is going to be the same. It's going to be consistent during these split operations. The errors should be near zero or zero. So the service knows where the data is always going to be. And so partitions give you scale and let the table hit the high levels of throughput. So putting it all together, because as you may recall, DynamoDB stores the data in 3 physical locations. We're taking your item. In this case, we have maybe an echo. I'm not sure which ASIN that is. And then we're running the hashing function. And so the output is 7B. And that means it's going to partition B. And partition B is in 3 availability zones. Can take it back one more time. It's in 3 availability zones. And it has just a subset of the key space. And then that's where we're going to store the item. Now let's get into some of the features of DynamoDB, things that released after the service launched in January of 2012. First is DynamoDB Streams. DynamoDB Streams provides you an ordered set of changes to your DynamoDB table. So your create, your update, and your delete operations create entries in DynamoDB Streams. They will appear exactly once, and they'll be there for up to 24 hours. So it lets you replicate the table to another region or copy all the changes to S3 using an open source library on GitHub, which copies all the changes to Kinesis Firehose, which then puts the changes in S3. And by using this Kinesis client library application, you can quickly pull records off your DynamoDB stream using a familiar interface, one borrowed from Kinesis Streams, and then process your records. Oh, and it's worth noting that DynamoDB Streams is a completely separate service from Kinesis Streams. Another feature that DynamoDB has is time to live. The TTL, it's really straightforward. It's used to control the size of a table. So if you have 24 hours of data that need to sit in there, instead of deleting it, and by deleting it, you're consuming write capacity units, let DynamoDB delete it for free. So it actually ends up lowering your cost. And so TTL uses an epoch timestamp. It's a number of seconds since Jan 1, 1970. And that timestamp is read through a background process by the stream service or by the DynamoDB service for free. And then that delete will show in the DynamoDB stream, so you can identify that the Dynamo service is the one that expunged the row. You can monitor access to TTL by looking at CloudTrail. And please note that stale items may be returned. You do need to do some client-side filtering because at its core, TTL controls the size of the table and lowers your costs on provision write capacity. We have a customer, Tune, which saved over $1 million a year by enabling TTL because they no longer had to pay for write capacity to go delete tables. They didn't have to pay in US East 1, the 25 cents per gigabyte a month to store the data. And speaking of controlling costs, we have tags. Tags are available with DynamoDB, so you can add a tag to a table, and then you can go to the Cost Explorer and find out which unit was responsible for the cost of a DynamoDB table. It's something that a lot of customers are happy about because they want to be able to use a DynamoDB, but they want a similar billing experience to a relational database like RDS, and now DynamoDB supports cost allocation tagging. Now, this is a really exciting service, DynamoDB auto-scaling, because it also lowers costs for our customers. It controls the provision capacity of the table, and it tries to match the consume capacity. So if you have a periodic workflow that increases maybe during North American daytime hours, when users are kind of waking up, you can use DynamoDB auto-scaling to kind of stay on top of that. And if you, do note it has about a 5-minute response time where it's going to be about 5 minutes to increase capacity after you break your target utilization level. So for faster response, you may want to use something like Dynamic DynamoDB, which we have on our website. You choose the target utilization, which is a percentage of consumption that you want the table to be in. And of course, you can control the cost by setting the minimum and maximum provision capacity. Now, let's talk about DynamoDB in the VPC. That's something that was very popular this year. Released two features. One is DynamoDB Accelerator. The other is VPC endpoints. And it brings DynamoDB into the VPC without the requirement of an IGW. Now, first, let's talk about DynamoDB Accelerator, also known as DAX. DAX is an in-memory write-through cache that accelerates read operations. It operates in a cluster form. It's a drop-in API compliant with existing SDKs, which are available as of right now in Node.js and Java. So by simply pointing your DynamoDB table at DynamoDB Accelerator and changing the configuration endpoint and making no other changes to your code, you don't have to change your operations. You can accelerate your read operations. It takes the latency for reads from milliseconds to microseconds, and it scales to millions of requests per second because DynamoDB Accelerator operates in a cluster mode. In addition, it sits inside your VPC. It has a security group. It has a private IP. So if your application is already running in a VPC or even through a Lambda function, running a Lambda function with access to the VPC, you can use DynamoDB Accelerator and not even leave your own network or maybe even stay inside the same availability zone. I also need to mention the VPC endpoints. Now, in the past, customers would configure NAT instances or use NAT Gateway, the service, to bridge the connection to DynamoDB. But with VPC endpoints, you can contact DynamoDB at no additional cost. And so if you have instances that are inside the VPC, in the past they could contact S3 without leaving the VPC, and now you can do that for DynamoDB. So in summary, DynamoDB Accelerator, private IPs, client-side discovery using a configuration endpoint. We have two SDKs available. It works in cluster, and it has a separate query and item cache. And I'll explain that one real quick. So the query cache, it's capitalized, the Q, because the DynamoDB query operation lets you read and write data into DynamoDB, and then the item cache stores the put item, get item, write item operation. Let's talk about hot shards in a NoSQL database. And NoSQL, in say a kind of on-prem or even managed EC2 database, you won't notice, or you might not even notice, the slow query times. You might go look at the load, notice there's load, you might see the IO wait, but it's not immediately clear that you have a hotkey. And so a hotkey is something like, host 3 has my particular key, my hot product that's selling like hotcakes, and I'm going to overload it. So how do I know that that's happening in DynamoDB? Well, in Dynamo, we have this idea of throttling. Throttling is a provision throughput exceeded exception. So when you have a non-uniform workload or mixing hot and cold data, the throttling exception will be created. And we suggest customers disable the retries, write your own retry code, and log all throttled keys, because DynamoDB is not going to give you any indication of which keys were causing the throttle. Now we're going to get into design pattern here. First, we've got a dating website. The dating website, this is based on a real-world customer. They need to be able to accept likes between users. I like you, you like me, and then they need to be able to match them. And for our purposes, we have an hourly batch job to match the users. So here's the query. We need to get all the people that I like. We need to get all the people that like me. And we need to expire data after 30 days. Now, the last one's easy. We're just going to add the myTTL attribute. But how do I get all the people that I like? Well, the easiest thing is to create a likes table with my user ID, and then I'm going to like some other person, which we're just going to call other. And then we create a global secondary index on the other attribute. So I can query either the likes or the GSI other database to find all the people that I like or all the people that like me. Now, once I have a like, I need to find out if there's a connection between the two of us. So I create this matches table. The match has a unique ID, an event ID, and it has two users, the left user and the right user. The left user could be like user 1, right user is user 2. So if I want to get my matches, I might be user number 1 or user number 2. So I have to query the left and the right global secondary indexes to find whether I've matched. So here's what I've done. I get the likes every hour. For each like, I'm going to get the other user's likes, and then I'm going to store the matches in the matches table. But here's the problem. I'm running every hour, and I'm going to get a hot partition because I have an imbalance in access. And what are we doing wrong here? First, we're violating this tenet. We're not evenly spacing our requests over time. So what we're going to do is introduce DynamoDB Accelerator, and we're going to use a little bit of a trick. We're going to write to the like table, and then we're going to query DAX to warm the cache, and then we're going to queue it for batch processing. So what we're doing is instead of we have 3 arrows from the application to DynamoDB, we only have 1 arrow to simulate we have just 1/3 of the read capacity being consumed in that moment. So by warming it in cache and considering DynamoDB Accelerator can hold up to 240 gigs of data, we're letting that EMR job run for a very short amount of time. And considering that EC2 now bills for a minimum of 10 minutes, you can launch an EMR cluster, have it wrap up really fast because of that high granularity building, and you're saving money both on EC2 and on DynamoDB provision capacity by querying, even though you don't need the result, but pulling it into the cache. So keep DAX warm by querying after writing, and use GSIs for those many-to-many relationships. Now, the second pattern we're going to get into is a serverless IoT pattern. So this could be all these devices that are in the field, maybe a sensor in someone's car, maybe in a bus, and this data needs to be stored for a very long time. So we're going to archive the old data to S3. And finally, we're going to store the data in a data table, a single table. We're not going to use any time series tables for those of you who may be familiar with those. So what we have is a data table with a device ID as a partition key, and the timestamp when the data is created is the sort key. And so this is going to let us get all the events for a day. And then for the second requirement, we're going to add the TTL attribute like we had in the previous design, and once it's expired, we're going to have to write that to S3. Now, the user devices table has a requirement of getting all devices for the user. And so we're going to be able to query the user devices table each time we see device ID. So maybe we can include the user ID in the data table for quick views. So what we've done in this pattern, we set up DynamoDB with DynamoDB streams. We have every record, every deletion going into streams, and streams is going to copy directly to S3. So we've done a couple of things. We've got a single table, we have tiered storage, and we have obviously the single data table. Now here's the problem. I enlarged this bus to give you a visual representation of this imbalance. Data will always be noisy. Maybe you have a developer trying a new application. Maybe it's running on his laptop, and he's generating at 5 times the rate of everything else, and he creates a hot partition. We create a throttle. And so noisy sensor data, eventually will create an imbalance. So how do we handle that? What we see here is that we're violating a tenet on even access. So we have that large bus that's sitting on there on partition C. It's not evenly accessed over the key space. So we're going to add a new requirement. We want to add dynamic sharding to overcome throttling. Dynamic sharding is going to change what the keys are to evenly distribute data across the partitions. So we have a brand new table called shard. First, we're going to get the shard count for a given device. And the second requirement is they're always going to grow the number of shards. And let me show you what this looks like. The read request path is going to first look at the shard table and get the shard count. In this case, it's a count of 10. Then we're going to write to random shard. We chose shard 3. And then if we have a throttle, we're going to review the shard count, circle back and find a new way to shard the data, maybe just increase from 10 to 100. So taking you through a slightly different way, we're going to query on device ID of 1. There's 10 shards. We're going to pick a random number, and that item would end up in one of those partitions. And then when I need to query all the data to read out, I'm going to need to query for device ID underscore 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 separate query operations to assemble the data. So here's the final design. We have the shard table. We have the data table. We added in DAX, DynamoDB Accelerator, to offset the high reads on the shard table because it's going to have hot partitions if we don't do that. So DAX is going to store the shard information maybe for TTL in 5 seconds. And we're also adding Kinesis Firehose on the right side because we want to batch the changes to S3. It's an anti-pattern to store rows to S3 with the same key prefix. By using Kinesis Firehose, we batch together up to 128 megabytes of rows into one object in S3. So use this pattern called naive write sharding to dynamically expand shards, don't hard code them. Use DAX for hot reads, and use TTL with DynamoDB streams for tiered storage. So looking forward, you can use DynamoDB Local if you want to get started today. DynamoDB Local is available at no cost. It's in Maven. It comes as a jar. It's basically a local application that runs on your laptop, on your computer. and then you use your localhost IP as your endpoint. It'll let you test your DynamoDB code without calling a real DynamoDB table. It's great if you're on a plane, you're in a low bandwidth situation, or you're a student in a class. In addition, we have a great developer resources page with all sorts of community plugins, tools that have been written by customers like Mapbox. You can find quick start guides on developer resources. And finally, I would be remiss if I didn't mention the document SDKs available in languages like Python and Java, which simplify the access of DynamoDB. Lets you create native data type like use a dict and store directly in DynamoDB without concerns about encoding and stuffing the item into the API. So thank you very much for your time. That being said, we're going to open up to questions. Please type your questions in and submit them, and I will go through them now.